Hi, my name is Kenneth Auge. I'm a technical advisor with Innova. Been with Innova since 2018. I'm going to show you some of the important steps with fiber optics and the use of the matrix and show you how the insertion loss and the loss on each channel is showed and viewed on the matrix. The matrix comes with a spare bulkhead, which is to be mounted in the junction box on your vessel. This is with a 20 shell size interface. When connecting the fiber optics to the matrix, it's important to have the fiber ends clean. In order to clean the fiber, we use a click pen. There are several other ways to clean the fiber, but this is what we use. Simply press twice and the surface should be clean. With the matrix from serial number approximately 194, we deliver a attenuator for the fiber. This one is on 15 dB. This is to simulate the system when you connect it. When you bench test the matrix before installation, you need to use an attenuator. That's because the signal level from the laser in the subsea and the topside is too high, and you risk damaging the SFP transceivers inside the matrix if you don't use it. When connecting the attenuator, clean the surface on the attenuator as well. In a ROV system, there might be 3 kilometers of fiber, 2 slip rings, one on the winch and one on the TMS, and several other connections between topside and down to the subsea. All these things, all the 3 kilometer fiber, those 2 slip rings, and all the connections in between will normally add up to a place between 10 to 20 dB loss on the fiber. The matrix can handle a loss up to nearly 20 dB, which says that if you are in the area of 10 to 20 dB loss, you should be fine. On the matrix, we got this link tab where all the transceivers, all SFP transceivers, is lined up. We got one, which is the one for the AV card. The DV is the digital video, and the Ethernet is the Ethernet card. The AV card has one SFP up and one SFP down. The DV card only transmits data, so that the transfer is from subsea to topside. The Ethernet has 3 channels and one SFP for bottom and one SFP on top. An ideal loss from topside to subsea is in the area of 15 up to 25 dB approximately. You will read when you connect an attenuator on 15 dB, and in addition got all the connections. You will read in the area between 16 to 19 dB on the AV card. This is the overall loss on the system. So remember, if you got a loss on your system, which is 20 dB, you will read a higher dB on the system, because the topside, all the connections between subsea and topside is added on top of that loss. On each SFP, you got the temperature reading, which is the temperature reading. This one is the temperature reading on the subsea. This shows the transmitted power, and this shows the received power. Each SFP transceiver has a wavelength. This the span on the wavelength, which is on the matrices, is between 1291 up to 1611. The top green lights are the SFP top side SFP transceivers. The information same there, with the temperature and the wavelength and so on. If you see a red light on either top or bottom, that might indicate there's a faulty SFP transceiver, faulty CWDM, that's where all the lights are transmitted, or a faulty CWDM that receives the light.